Okay, guys, so we're going to look at reciprocal functions. And remember, the parent graph for this is the following. And this is the graph of y is equal to 1 over x. Now, this one's a little bit different, and the reason it's a little bit different is there are these things called asymptotes. Oops. No, sorry, I don't. Wait 1 second. I want to spell this right. So, in this case, for the parent graph, the asymptotes are the lines x is equal to 0 and y is equal to 0. And what that means is, as these graphs approach infinity, they get closer and closer to 0, but they don't actually touch 0. So remember, if you plug in a really, really big number for x, you get a number that's really, really close to 0 for y. But you never get 0 because you're dividing one thing into a bunch of pieces, so you'll always have some amount of piece left over. And similarly, if you set y equal to 0 is equal to 1 over x, when you multiply this, you get x times 0 is equal to 1. Well, that's not possible because anything times 0 is never 1. It's always 0, and so that's not even possible. Okay, so you can see that there are some discrepancies that happen at 0 and 0. But that doesn't mean that your asymptotes have to be at 0. So for instance, if I give you y is equal to ax, the formula for this should be x minus h plus k. Okay, so let's look at this. If I give you y is equal to 1 over x minus 2 plus 1, what's going to happen is this asymptote for x is going to actually change to x is equal to 2, and the asymptote for the other one is going to equal to y is equal to 1. And so what that looks like is you draw your graph, you go to x is equal to 2. Remember, x is equal to 2 is a vertical line, so we draw a vertical line. Okay, we got a 1. It's here. So at 2, 1, that's where these asymptotes occur, and then we just can kind of draw our graph as we've been before. Okay. And there are some more tricks that go along with this. You can have rational functions are not confined to just looking like this. You can have things that look like the following. You can have 2 asymptotes and things like that. And with that being said, these get a lot more complicated, but our focus here is just on the transformations. And so we're going to stick to that for now. So that's just a quick little transformation thing with these asymptotes and reciprocal functions. The next one I want to talk about is the absolute value function. If we have y is equal to the absolute value of x, remember it looks like this. So I've already got it graphed out. But let's say that I change it. I say y is equal to negative 2 x minus 3 plus 4. Okay. Well, h here is 3. K here is 4. And a is negative 2. And we haven't talked about negative a value yet, but what do you think it does? So if you have positive this, remember if you have y is equal to x squared, you have a parabola facing like this. Well, if you have y is equal to negative x squared, it turns into this. And so that negative will flip it upside down. And so the 2 is just going to scale it a little bit. It's going to be a little bit steeper, quicker. And the negative is going to flip it upside down. So I wanted to actually look at this with Desmos. We want negative 2 for a, 3 and 4. Okay, so let's go to Desmos. So first things first, I want you to notice this is the graph of y is equal to x, absolute value of x. This is the graph of y is equal to a minus, or x absolute value of x minus h plus k. They're the exact same graph when a is 1, h is 0, and k is 0. Why? Because if a is 1, you're multiplying that absolute value by 1, and if h is 0 and k is 0, that means there's no shift. So let's see what happens when we move this. And as you see, if you move it positive, if you move it to 3, it shifts everything over 3 points. We want 3, 4. Okay, so 3, 4 is going to bring it up and over. But then we want -2. So watch what happens. As it gets smaller, it kind of shrinks. And then it flips upside down when it's negative, and we go to 2. And so the blue would be the graph of the transformation, and the red would be the graph of the parent graph, the absolute value function. But if we look at 2, I just want to show you what I mean by the shrinking. I'll move this back to 0, 0. You can see what I'm talking about. It kind of shrinks it. It gets taller quicker because it's being multiplied by 2. And so it kind of makes the steepness change. And if we go even further, it gets even steeper, even faster. And so kind of like, I guess we call that a stretch. So keep these things in mind, guys. You want the absolute value function as a v, you want h and k, that's always the same, and you want a to be some multiple of something.